Good evening. I hope my screen is visible and you can hear me. So, today we are going to do a revision session. We'll be revising all the weeks from week 1 to week 8. And I hope all of you have these links. All the YouTube live recording of the TA sessions are in a YouTube playlist, and all the presentations are also uploaded on a Google Drive. And so these are some old announcements that are important for the exam. You will not be uh, allowed to use R coding, like you can't write R script, uh, uh, but there will be some questions from R based on like some functions and the arguments to the functions and so on. So these are the topics that we discussed. So we started with some basic concepts of probability and statistics, and then we also discussed some linear algebra. So because these are the basics for many of the data analysis techniques, and then we then moved on to using R, so how to uh, like some basics of R, and then how to draw graphs, different types of graphs in R, and then we went to the data analysis techniques like correlation and regression, and then we also looked at clustering and classification. Both we looked at both supervised and unsupervised machine learning, and finally in the last week, which was just yesterday, we looked at the analysis of higher dimensional data and how to do dimension reduction. So let's start with week 1, probability. So revision of the concepts, I'll be going a bit fast, uh, but I think because it will be more useful for you to solve practice problems, I believe. So, and because we have to revise all the 8 weeks portions, I'll be going a bit fast in the revision, but you can take your time to solve the MCQ questions. So these are some of the basic concepts. So probability is um, it is a number between 0 and 1 which says how likely an event is to occur. So 0 means that the event it is impossible, and 1 means that the event will definitely occur. And there are two important rules in probability: the addition rule and the product rule. So addition means if you have mutually exclusive events, then if you want to know the probability that any one of them will happen, then you can just add probability of A plus probability of B. And product rule means if you have two independent events and you want to calculate the probability of both of the events happening, then you have to multiply the two probabilities. And then we discussed about continuous normal probability distributions like the Gaussian or the normal distribution. Let me see if I can draw. I'm not able to draw this. Okay, anyways, I'll just go ahead like this. Yeah. So, and then in a continuous probability distribution, to get the probability of the random variable being between A and B, we have to integrate with the limits as A and B. And then we looked at the first moment, second moment, etc. So the first moment is nothing but the mean. So the moment just means the power here, like x power m, that m is the moment in this case. So first moment means we just add to the power 1. Like when you find the mean, you just add the each of the value without tracing it to any power, because the power is just 1. And then we discussed conditional probability. So conditional probability P x bar y means probability that x will happen given that y has already happened. And in conditional probability, one of the very important concepts is the Bayes theorem. It says that probability of y occurring given that x has occurred is equal to probability that x uh, occurs given y has occurred multiplied by probability of y, and in the denominator you have the probability of x. So this Bayes theorem, if you get any questions, if you know the Bayes theorem formula, then you can just substitute the values and get the final answer. So now you can take a couple of minutes to solve this question. So these are questions that we have done during the TA sessions. So it will be helpful if you go through them again before the exam. Yeah. Okay, so some of you have got the answer. Uh, yeah. So this is based on the probability, continuous distribution of probability. So the main idea is that for a random variable which is having a minimum value of m and maximum value of n, if you integrate over the entire limits from m to n, then the sum of the areas under the probability curve would be 1. But in option A, it is given that it is greater than 1, so that is not correct. And in option B, they have taken an intermediate number A to M, they are saying it is 1, but that is also not correct because from m to n it has to be 1. You have to take the entire range of the random variable, only then it will be 1. If you take any intermediate range, then the integration would be less than 1. So that is why option C is correct, because a to b is not the entire range of the random variable, rather it is just an intermediate range. So option C is correct. And option B, they are adding two integrations. The first integration is from m to a, and the second integration is from b to n. But the problem is that the a to b range has not been considered. So if you add m to a to b, and b to n, only then it will be 1. But they have missed a to b, so option D cannot be equal to 1. So the correct relation would be option C. Now you can take a couple of minutes to solve this, and you can type the answer in the chat box, then we can discuss. Okay, so let's discuss the solution now. They are asking which of the following statements is wrong. So one way to do this would be to solve using the formula, solve what is the covariance, variance, etc. But we can discuss another easier way, where just by looking at the data we can guess the values. We can't get the approximate values, but we can try to guess it. So in option A, they are saying covariance of x and y is less than 0. So generally covariance less than 0 means that if x increases, then y has to decrease. They have to have opposite trend. But if you look at the table given here, x is increasing, like it's going 10, 15, 20, and y is also increasing. So in this case, the covariance would be greater than 0. But in option A, they are saying it is less than 0, which is not correct. And option B, variance of x greater than 0. So this is also expected, because x is having 5 different values. So the variance will be greater than 0. So that we can say just by looking at the data. So option B is correct. And option C is expectation of y greater than 0. So expectation of y, I hope all of you know that it is the same as mean. So you can see that the values are 0, 5, 10, 15, 20. So easily you can say that the mean will be a positive number, because all the values of y are positive. In fact, there are no negative values. So the expectation of y has to be greater than 0. And option D, they have given expectation of y minus expectation of y. So this is just the same as the formula for variance, if you remember. And similarly, you can see that y is having, there are 5 values of y and all 5 values are different. So obviously the variance has to be greater than 0. So they are asking which is wrong. So option A would be the correct answer. I hope this is clear to all. Now let's go to week 2. So in week 2 we discussed some basics of vectors and linear algebra. So with vectors you can do a lot of products like addition and scalar multiplication. So scalar multiplication will just uh, it will keep the direction same, and the magnitude of the vector will be multiplied by the whatever number we multiply. And dot product is done between two vectors, and the final answer would be a scalar. And then we can also project a vector to the, like for example you can project it to the x-axis or to the y-axis. And when two vectors are orthogonal, so orthogonal means they are 90 degrees to each other, then their dot product would be 0. And then we also talked about matrices and how we can which is like a table essentially. And once we have it in a table form, then we can do different operations like addition and multiplication, etc. And this is another important concept, that is eigenvalues and eigenvectors. So eigenvalue, first thing you have to remember is that it is for a square matrix and it has to be a non-zero vector. So eigenvector will the idea is that when you multiply a matrix by its eigenvector, then the answer that you get will be a multiple of the eigenvector. So that is the formula. AV is equal to lambda V, and it is only defined for square matrices. And for the number of eigenvectors will depend on the number of rows and columns in the matrix. And then we also discussed about symmetric matrix. So symmetric matrix means A equals A transpose. That is, when you interchange the rows and columns, you will still get the same matrix. And then we also discussed about how to solve a system of equations. Yeah. So to solve a system of equations, you can write the system of equations in a matrix form, like Ax is equal to B. And then when you multiply both sides by A inverse, you will get x equal to A inverse B. And the number of solutions will depend on the number of equations that we have and the number of variables that are there. So if the number of equations and number of variables are equal, then we get one solution. If the number of equations are less than the number of variables, then we can't solve it. It is an overdetermined system and we don't get any solution, no solution. And then we also have underdetermined, when the number of equations are more than the number of variables. So now you can take a couple of minutes to solve this, then we can discuss. So in this question they have given us three vectors A, B, C, and we have to find out which of the following is meaningful. So if you look at option A, first they are doing a dot product. So dot product is allowed between two vectors. And if you remember, dot product between two vectors will give a scalar number. Actually, I'm not able to see the teams during. Okay, so you have written option B. So and then yeah, so A dot B will give a scalar. So and then they are trying to do with the scalar. They are trying to do another dot product, but that is not possible because dot product is between two vectors. And option B is first they are doing dot product, so that is allowed. That will give a scalar, and that scalar they are multiplying by a vector, so that is option B is fine because it is a scalar multiplication of a vector. And option C again, A dot B will give a scalar, and they are trying to add scalar plus vector, so that is not allowed. And option D also again they are trying to they are first finding modulus of A, which is a magnitude of A, which is a scalar, but dot product with the scalar is not allowed, so option D is also not correct. The correct answer is option B. Let's go to the next question. So let's discuss this solution now. We'll go a bit fast because we have to cover all the weeks. So they are saying matrix W has 4 rows and 6 columns. So number of rows and number of columns are different. So it is a rectangular matrix. It's not a square matrix. That is not correct. And then option B is about W inverse has 4 columns, and option C, W transpose W is a square symmetric matrix, and option D, W has 6 eigenvectors. So option A we discussed, it is not correct because it's a rectangular matrix, and option B is also not correct because it is for a square matrix only we can define W inverse, but this is a rectangular matrix. And option C is they are multiplying W transpose and W. So W transpose is a 6 by 4 matrix because W is a 4 by 6 matrix. So when you multiply 6 by 4 and 4 by 6 matrix, we get a 6 by 6 matrix, which is a square matrix. So option C is correct. And option D again there it's about eigenvectors, but we saw that eigenvectors can only be defined for a square matrix, but this is a rectangular matrix. So the correct answer is option C. You can take a few minutes for this, then we can discuss it. So in this, let's discuss this now. So the correct answer would be, so to get the correct answer, you have to compare the number of equations and number of variables. Here we have two equations, but there are three variables. So it means that it cannot have a solution. So this is from the concept we saw already. Yeah, that when the number of equations are more, then it is overdetermined and it does not have a solution. So this is an overdetermined system of equations because there are three equations but only two variables are there. And then in week 3 we covered the basics of R. Um, so these are some of the symbols that you have to remember. And then we also discussed some basic matrix operations in R. So you can go through this question for a couple of minutes, then we'll discuss it. So in this question they are asking which function will give us the transpose of a matrix, and the correct answer is the function T, and the argument you have to give is the matrix M. So let's go to the next question. So this question they are asking which function is used to get the number of elements. So the correct answer is length. So if you use the function, you can know how many elements are there in a vector. And here they are asking what is the output of the code. So here in this code, first they have assigned A to 10 and B is assigned 3. So C is assigned with an AND. So C will be either true or false. And the AND statement is between two conditions. Um, the first one is A equal to 10, so that is true. So B equal to 2, that is false. So C is true and false. And true and false based on logical operators for an AND operation, even if one is false, then the answer will be false. So print C will give us false. The correct answer is option B. So we'll discuss one last problem in this week, then move on to the fourth week. So in this question, they are using the solve function, which is used to solve a system of equations. So here you can see the first row is 1 comma 1 and the second is 1 comma minus 1, and the constant term is 2 comma 0. So basically we have to solve the equations x plus y equal to 1 and x minus y equal to 0. So this is very straightforward. So the solution to this will be x equal to 1 and y equal to 1. So the correct answer is option A. I'm not able to use my pen today, otherwise I can write and show it, but I hope you got it. So the first equation is x plus y equal to 2. So x equal to 1, y equal to 1 will satisfy it. And the second equation from, because the numbers are 1 comma minus 1, yeah, I'm not able to use the pen. Okay, I'll just explain it like that. And the second equation is x equal to y. So in this case, x equal to 1, y equal to 1. Both are equal. So, and then in the next week, we covered data visualization. We looked at how to use different kind of plot like scatter plot, line plot, and box plot. Let me just check how to use the pen, then it would be easier for me. To select this. I'm not getting the pen option. Just give me a minute. I'll try to switch on pen. Let me see if I can draw on the PDF. Okay, I'm able to draw in this, so we can continue with the PDF version. So we were in week 4. So scatter plot is an x versus y plot, where for example this value would mean that x equal to 1, y equal to 1. And this value would mean x equal to 2, y equal to 2, and so on. So this is a scatter plot. The dots can be anywhere depending on the values that we get. And line plot means all the values will be connected by a line. So this is a line plot. And then we also have a something called as a bar plot. So where the maybe on the x-axis you have so this is maybe you're counting number of chocolates of different brands in a shop, and this is brand 1 and brand 2. Maybe this is 20 chocolates and this is 15 chocolates. So this is an example of a bar graph. And then a histogram will show the distribution. So this would be x. This is the variable x, and maybe it's taking values like 1, 2, 3, 4, 5, 6. Maybe these are so let's take an example where you collect leaves, different leaves, and you measure the length of the leaves. So this is the leaf length, and basically you are counting how many leaves have a length of 1 centimeter, how many leaves have a length of 1.5, how many leaves have a length of 2, and so on. Like you count it and you make a graph like this. So this is giving you the distribution of the leaf sizes. This is a histogram. And you can also make a box plot. For example, you're seeing treatment, uh, maybe again you're looking at the leaf length, but you're comparing the leaf length of tree 1 and tree 2, like two different trees. So you collect many leaves of tree 1, and each of them, like this, there are some leaves that have lesser length and some leaves that have lower length, and then you also do the same for the tree 2, and then you make this box based on the quartile values, and this is the interquartile range. So this concept of interquartile range we will be discussing in the MCQ example, so we can understand more there. And similarly for these values also, you make the same box based on the quartiles. And then you can also have a heat map where you are looking at things in space. For example, you have this is a tissue section, and in this tissue section different regions have different levels of gene expression. So maybe in some of the regions of the tissue the gene expression is high, so they will get a dark, maybe red color coding, and in some of the regions the gene expression is low, so they will get a light or blue color coding. So in a heat map the data is represented using colors. So these are the main type of plots that we discussed in lecture 4. Now let's go to some problems. You can take a couple of minutes to solve this problem, then we can discuss the solution. Oh, I think I was muted. Sorry. Actually, I'm presenting on PDF, so I'm not able to see the Microsoft Teams screen. Okay, sorry, I'm just seeing the messages because I was in the screen share mode. I could not see the Teams. Yeah, so we are in week 8 now, and PCA is a dimensionality reduction technique. So if you have cell 1 like hundreds of cells with each having 10 genes, then it is not possible to plot all of them. So instead of that, we find the important components, that is the principal components, and each cell is represented in this principal component axis. And then the second is the t-SNE plot, or TSNE. So this we have seen it often in the context of gene expression data. So you have like maybe this is a cell type which has this gene expression profile, and then you have some more cells with a different gene expression profile and so on. So this is a t-SNE plot. So this T here stands for the T distribution, and the SNE stands for stochastic neighbor embedding. So the sixth question is, which of the following algorithm is usually recommended to be performed before t-SNE on data with a very large dimension? So this t-SNE plot is based on the principle of distance reduction. So if there are too many variables, then it can get very computationally expensive. So that's why first it is better to do instead of directly doing a t-SNE, it is better to do PCA and then reduce the dimensions and then do a t-SNE. So this will make it a little bit faster. So the correct answer is PCA to reduce the dimensionality. Then the next question is, in PCA we project the data on eigenvectors. So these eigenvectors are nothing but the principal components, and these are stored in the, so these eigenvectors are the principal components, and these are stored in the covariance matrix. So this is the first step of PCS to get the, so first step is you get the covariance matrix, and then you get the eigenvectors, and from the eigenvectors you can get the principal component. So maybe initially your points are like this, and then you find the principal component. So you have to project each point. So then once you find the principal component, you have to project the points on the principal component, and these projected points are stored in the scores matrix. So the correct answer is option C. Yeah, so this is the final question. Not able to, sorry. So the question is, why do we use set seed function while performing t-SNE in R? So this set seed function, it is used for initializing random numbers. So for Disney, if you know the procedure, first it is based on the initial um, random numbers that are generated, like the initial class positions that we get. But um, so the results of the Disney will depend on the initial random localization that we do. So the problem is that each time if we do a random localization, we will be getting different outputs. So to prevent this, we use a set seed with the random number generator, so that each time we get the same random numbers and the same output. So this will set the seed for the random number generator, and if the initial localization is the same, then we can get reproducibility. So the correct answer is option B. So that's it for the session today. We have discussed all the week sessions. Yeah, and we have also practiced some example problems. So if you have any doubts, you can stay back. Otherwise, we can finish the session for today. I'll upload this PDF on the Google Drive, the same Google Drive where all the PPTs are. And sorry about the microphone issue. I could not see the Teams chat at all. Yeah, so for your final exam, you'll be having MCQ type questions that we discussed. Yeah, and you won't be asked to run any R script, but you will still get MCQs based on R functions, like the ones that we discussed today. Any other questions? I think. Number of questions, I'm not so sure. No, it will only be MCQs. At least that's what the NPTEL has told me. Number of questions, I'm not so sure. You can ask in the discussion forum. Okay, so I guess if there are no other questions, we can end the session for today. Good luck for your exams.